Hi guys, welcome back to Road Tutorial Chapter 4. And now we were going to start coding our n-bit adders. Okay, so let's begin by creating our main functions. So our main function will take two inputs, logic A and also logic B. We also want to create a function that encapsulates the logic of n-bit adder. So our n-bit adder will take on two inputs, logic A and also logic B, and return a logic value. So in this case, we're going to have like an A and B with the name of AB and then the width of 8. So no, this one is a mistake. Okay, so final sum is going to be n bit adder A and B. Now we also need to create a test. So we learned about test like last chapter, right? So test is going to have a test description. Our test description is going to be should return 10 when both input is 5. So say that when we deposit signals of 5 to A and B, it's going to return 10 for our sum. Okay, so we also need to have MB adders that just give a placeholder of constant 0 to make sure at least you can run the code. Alright, so if you run the code, you will see the test fail. Because why? It's expect the value to be 10 instead of our hard-coded value of 0. However, this is not a problem since we can make it work in the next step when we start to create about the Dart function and class. Alright, so let's go back to our code. Yeah, so just let's start by importing, like roads, like package dot road dot dart, and yeah, just start by creating a main function here. So in our main function, we need the logic of A and B, right? So just say that the name is going to be, like A and just give it the width of, like 4 in this case, because we're going to create a 4-bit adder, right? Then the next thing is we need a logic of B, and it's going to be the same. Just give it a name of, like B and the width of 4. Okay. Okay. So the next step is we're going to create a sum, the logic of sum. Logic of sum is going to be equal to the result of the n bit adder, right? So say that when we pass a and b here, it's going to return a sum. So let's create a test here. Okay, so just say that should return 10 when both a and b is 5. Alright, so just create a function. So let's deposit a signal like a dot put, let's say 5, and same thing, we're going to put value of 5 to b, and we expect it to return, like sum dot value dot to int is going to return we're going to return tens, right, equal to tens. Okay, so because you can see from here, we doesn't detect that say that np adder isn't defined. So let's quickly create a function called nbit adder, right? Okay, so nbit adder, what it's going to return is going to return a logic sum, right? So just create a logic of nbit adder, and as for now, let's just return, like constant 0 as a placeholder here. And it's going to nbit adder is going to take on two variables, right? A and B. Like this A and this B. So what we're going to do here, we're going to say like we're going to take A, logic A, and also logic B as the argument of the function. Alright, so let's try to run, and it should fail. It should say like, oh, I expect our code to return 10, but instead I get 0. Something is wrong with your code. Please fix it. Yeah, well, everything is under our control. Don't panic. Yeah, so the next thing you want to do is to create a Dart function and class. So if we look back the n-bit adder diagram, from our previous section, we can see that n-bit adder is simply just repetition of the single full adder from our previous tutorials. You can see here. Full adder, full adder, full adder, full adder, set it in like A, B, you know, like I know A, B, like A, B, and I carry in, and it's going to return a sum. And then the output of the carry in is going to be the input of the next full adder. So everything is just repetitions. Is when we talk about repetitions in programming, the first thing that's come into our mind is going to use like, hey, just use for loop or while loop to get your work done, right? Yeah, well, if you think something like that, yeah, you are on the right track because we're going to use for loop to generate our full adder. So let's start by creating a full adder. So we have a full adder that takes in like logic A, logic B, and logic carry in. So don't confuse with the logic that we created just now. This logic is going to be 1 bits. It's going to be AB for the full adder inputs. Yeah, so don't confuse about it. This AB here is different from the AB that you define in here. This one is going to have like any bits that user want. It's going to be your n bit adder ends. Okay. In this case it shows like 8, right? Okay. So anyways, let's go back to this code here. We have a full adder, and here the logic of the full adder I'm not going to mention it in this chapter since I already demonstrate and mention it in the last chapter. So if you are still not sure like what is n1 and what is n2, please go back and check on the last chapter. Yeah, so I'm sure that you can understand better. So in this chapter we will be just totally focused on what is n-bit adder. So the n-bit adder, I mean like the full adder will return two things here. So the first thing is sum, the another thing is cout. So we can see from here, when we give full adder like A, B, and carry in, it's going to return a sum and a carry out. Okay, right. So in this case, it's going to be A, B, carry in, return two things, sum and carry out. So how we want to return two logic from a single function in this case. So we need a container to wrap it. So how I'm going to do it, I'm going to create another one class called full adder result that have the property of sum and also cout. So in this case, it's going to return an full adder result object that contains property of sum and cout. Okay. So you know what? I just going to copy out this one since this is going to be the same things that we have like in the last tutorials. Yeah, feel free to do it on your side as well if you feel like it's going to be the same thing. Just that instead of how we're going to assign our sum and also carry out, we need a full adder result. So just quickly create a class for the full adder result, and this one is going to take on two properties, right? So fine, we're going to use logic. Yeah, so logic sum is going to be the logic of sum, right? Yeah, so it's going to be name. Okay, and then another one is cout. So let's quickly create cout as well. Let's define a property name going to be cout. All right, so now we have like full adders that can return the result of like the result of sum and so cout. The next thing you want to look into is complete our n-bit adder, because now in our main function we just use n-bit adder, right? Yeah, so just look at this code. So the next thing is we can remove the constant 0 from the n-bit adder function since we no longer need this placeholder, right? You will now fill the function with a concrete implementation. So let's start by ensuring that A and B input have the same width using an assert statement. Okay, so how we going to decide like how many bits of our n-bit adder, right? So say that let's say we have like A and B is both have the width of 4, it's going to be 4 bit. If I mean let me just point out, okay. So if A and B has a width of 8, it's going to be 8-bit adders. Yeah. So it had a width of 4, it's going to be 4-bit adder. Okay. So in this case, A and B, they must have the same width. If they don't have the same width, we want to prompt the user that, okay, so your A and B should have the same width. Okay, so the n is going to be a dot width, and then we're going to initialize our carry to constant 0. Why? Because the first one is always 0, because the carry in of the feather have nothing, right? So it's going to be 0. And then we need a list as well, a list that have the type logic that can save all the sum. After that, here comes our basic generations and the key for this chapter, which is a for loop that can loop through your full adder that takes a, b, and a carry. And then we also need to assign our carry to the C out. Okay. Now our carry in is going to be rest C out. Okay. After that, we want to add everything to the sum, and then because here how we actually want to keep track like what is the result being returned, we can create a list. After that, just push all the value inside the list, and it's like swizzle it all together from the right. So we're going to use r swizzle and read it 11010. So it's going to be sum add carry. Yeah, so return sum dot r swizzle. Yeah, okay. So maybe you're still confused. So let's just write the code, and it's going to be clearer in this case, right? Yeah. So let's get back to our code. The first thing what we want to do. The first thing is we want to make sure the width of A and B going to be the same, right? So we want to use a function called assert here. So A dot width, sorry, A dot width is equal to B dot width. Okay. And what's the message that we want to let user know when they are A and B doesn't have same width? We're going to say like A and B must have same width, right? Okay, so the next thing is final n. What is our n bit adder n? It's going to be either A or B width, right? So it is just going to pick A dot width, and then we also need to assign our carry. In this case, our carry, the initialize is going to be a constant of 0. Because why? Because it don't have any the initialize because the first initial carry is doesn't have any carry out, right? So it's going to be 0. Okay, and then we also need a sum. Okay, so this sum is going to be a list, right? Okay, so we want to say that, okay, so this list is just going to have like all the type of logic, so we can just write logic. Yeah, it's a good practice for doing that. All right, so let's create a for loop. So let's say int is going to be 0. Yeah, it's going to be always start with 0. And when I is less than n, so we want to increment this I. Oops. So we want to increment this I. Right. Okay. So just what we're going to loop actually. So we're going to, what is the repetitive stuff? It's going to be a full adder, right? So just write on full adder in this case. Full adder. Okay. Yep. So the carry is going to be carry. It's going to take on the carry for the first one. Okay. So but this A is going to be I, because it's going to take bits by bits, right? And then we also need something called, we also need like some variable to save our further result here. Okay, so the next thing we want to do is we want to assign the carry out from the current full adder to the carry in of the next full adder. So how we're going to do that? We're going to override this carry by saying that carry is going to be the C out. Okay, and then the next thing is we want to save the result into the sum.list, right? So sum dot add, we can add the rest dot sum. Okay, and then the next thing, if you think this is finished but actually no. There is another things that you want to do. If you see from a diagram here, the last bits here is we're going to save. Here is all the sum, and also the last bit of the carry out also need to be keep track. So in this case, so we can just say it's like sum dot add the carry. Okay. So the next thing is we want to return the sum dot r swizzle. So if you are not familiar with what r swizzle is, yeah, just feel free to check back the previous tutorials. Okay. So now let's run the code and see if it passes. Yeah. So now all the tests pass. So congratulations, you have finished created your first full address in this chapter. Until then, happy coding.